There's a machine sitting in eastern China right now. That just did something scientists said was physically impossible. Not difficult, not unlikely, impossible. For 70 years, every fusion reactor on Earth hit the same wall, the same invisible ceiling that kept unlimited clean energy just out of reach. Every time researchers pushed too hard, the plasma, the superheated fuel inside the reactor, would violently collapse, like trying to hold the sun in a bottle, and the bottle keeps shattering. Every lab in the world accepted this limit as a law of nature, and then China walked through it like it wasn't even there. What happened inside a reactor called East, in the city of Hefei, China, in early 2026 is not just a scientific achievement. It is the moment the entire energy map of planet Earth started to shift, and most of the world has absolutely no idea it happened. Stay with me, because by the end of this video, you're going to understand exactly what China just unlocked, and why the people in charge of global energy are paying very, very close attention. Before we talk about what just happened, you need to understand what this machine actually is, because calling it an artificial sun sounds like science fiction. It isn't. The sun, our actual sun, produces energy through a process called nuclear fusion. It works by smashing hydrogen atoms together so hard they fuse into a heavier atom. And in that moment of fusion, a tiny, incredible amount of energy is released. The sun does this billions of times per second. That's why it's been burning for 4.5 billion years, and it has 5 billion more to go. Now here's why fusion matters for us. Fossil fuels, coal, oil, gas, they work by burning stored energy. They're dirty, they run out. And the damage they do to the atmosphere is a problem every country on Earth is trying to solve. Nuclear fission, the kind of nuclear power we use today, works by splitting atoms apart. It produces no carbon, but it creates radioactive waste that lasts for thousands of years. Fusion is different. Fusion is the dream. Fusion uses hydrogen, the most abundant element in the universe. It produces 4 times more energy per kilogram than fission. It creates zero long-lived radioactive waste. And the fuel? You could get it from seawater. The oceans contain enough hydrogen to power human civilization for millions of years. If fusion works, oil is irrelevant, coal is obsolete, energy becomes effectively unlimited. That's why every major country on Earth has been chasing it for 70 years. And that's what China's East reactor is. EAST stands for Experimental Advanced Superconducting Tokamak. It's a giant magnetic bottle, shaped like a donut, that uses superconducting magnets to trap plasma heated to 150 million degrees Celsius. That's 10 times hotter than the core of the sun. They call it the artificial sun. And in January 2026, something happened inside it that rewrote the rulebook. Here's the problem that stopped fusion from becoming real. For decades, fusion researchers knew that to get more energy out than you put in, the holy grail of fusion, you needed to do one thing above all else. You needed to pack more fuel into the plasma. More density, more atoms, more collisions, more energy. Simple, right? Except every time they pushed the density up past a certain point, the plasma collapsed. It's called the Greenwald Limit, named after the physicist who first defined it in the 1980s. And it became one of the most frustrating walls in all of science. Imagine trying to fill a balloon past its natural limit. At some point, it doesn't stretch anymore. It just pops. That's what happened to plasma. Push the density too high, and the plasma goes unstable. It smashes into the reactor walls. The experiment ends. You start again. Every tokamak on Earth, from the massive international ITER project in France, to MIT's research reactors, to South Korea's K-Star, they all lived under this ceiling. You couldn't go above it. You could approach it. You could optimize around it. But break it? No one had ever broken it. Some scientists had theorized it could be broken. A framework called plasma wall self-organization, developed by French researchers, suggested that, under very specific conditions, the plasma and the reactor walls could form a kind of relationship, a balance, a state where the usual limits no longer applied. They called it the density-free regime. It was a theory, a beautiful theory. No one had proven it in the real world, until now. So what did the team at EAST actually do? Professor Ping Zhu and Associate Professor Ning Yan led the research, published on January 1st, 2026 in the journal Science Advances. Peer-reviewed, verified, real. Here's the short version. They figured out that the reason plasma collapses at high density isn't because of the plasma itself. It's because of what happens at the edges. When plasma gets too dense, particles start crashing into the metal walls of the reactor. Those walls release impurities, metal atoms that contaminate the plasma. The plasma gets polluted, it loses energy, it destabilizes, it collapses. The Greenwald limit isn't a law of plasma physics. It's a law of plasma wall interaction. And if you can control the wall interaction precisely enough, you can bypass the limit entirely. Here's what the ICE team did differently. During the startup phase of each experiment, before the plasma even full-formed, they used a specific type of energy injection called electron-cyclotron resonance heating. Essentially, they used targeted microwave energy to heat electrons in the plasma before the main discharge began. This optimized the plasma wall relationship from the very first second. It kept the walls clean, it reduced impurity contamination to almost nothing, and it allowed the plasma density to build steadily and smoothly, past 100% of the Greenwald limit, past 120%, past 150%, stable, controlled, unprecedented. They had entered the density-free regime, the wall that had stopped every fusion program on Earth for 70 years. China walked straight through it, and the plasma didn't collapse. It held. Now, let's talk about what this actually means, because this isn't just a science story. This is a story about who controls the energy of the 21st century. Right now, the global economy runs on fossil fuels. Every country that imports oil, which is most of them, is vulnerable to price shocks, to supply cuts, to the politics of the nations that sit on top of the world's reserves. Wars have been fought over oil. Entire foreign policies have been built around protecting energy supply chains. And here's China's position in all of that. China is the world's largest energy consumer, and for decades, it has been dependent on imports. But if fusion works, China doesn't need anyone else's oil. China doesn't need Qatar's gas. China doesn't need to maintain friendly relations with regimes it doesn't like for the sake of energy security. China just builds its energy out of seawater, virtually unlimited, at home. And it doesn't stop there. Right now, China is building energy infrastructure across Africa, Southeast Asia and the Middle East through the Belt and Road Initiative. Mostly solar, mostly traditional power plants. Imagine the leverage China would have if it could offer fusion power plants to developing nations. Clean, cheap, nearly unlimited energy, built by Chinese companies, using Chinese technology, serviced by Chinese engineers. That's not just an energy story, that's a geopolitical realignment. And the West? Where is the West in all of this? The International ITER Fusion Project, a 35-country collaboration including the US, the EU and Japan, has been under construction in France since 2013. The budget has ballooned to over $20 billion. It won't produce its first plasma experiment until 2033 at the earliest. MIT and several American startups are working on private fusion reactors. Some promising work, years away from ignition. Meanwhile, China just quietly confirmed a theory that changes what every future fusion reactor on Earth needs to be designed around. China isn't just participating in the fusion race, China is pulling ahead. So what happens now? The East team has already announced their next step. They plan to apply this same density-free approach during what's called high confinement mode, the most advanced, highest performance operating state a tokamak can run in. If the density-free regime holds at high confinement levels, we are not talking about years until ignition. We could be talking about something that changes every timeline we've ever projected for fusion energy. And East isn't even China's most advanced reactor. China is currently building BEST, the burning plasma experimental superconducting tokamak, a next-generation reactor specifically designed to achieve burning plasma. That means a plasma that sustains its own fusion reaction without external energy input, the point of no return on the road to a real power plant. BEST is scheduled to be operational by 2027. Now factor in the East breakthrough. Now factor in China's $135 billion AI semiconductor import surge, a sign that Chinese engineers are using AI to model and optimize plasma behavior at a scale no human team could do alone. And now factor in that China is also developing its own version of a low-orbit satellite network, not just for communications but for computing, a new kind of infrastructure designed to run the most demanding simulations in history. This is not one breakthrough. This is a coordinated national program, with more funding, more engineers and more political will than any fusion project in history. The question the rest of the world needs to ask is not if China achieves fusion. The question is whether anyone else will achieve it first. Let me leave you with this. In 1905, a 26-year-old patent clerk in Switzerland published a paper that contained the equation E = mc squared. It was a theoretical paper, abstract. Almost nobody read it. 20 years later, the world understood that this equation meant energy and matter were the same thing. and that splitting atoms could release power beyond anything humanity had imagined. 40 years after that, the first nuclear power plants came online. 70 years after that, the world still runs on coal and gas, because the clean version of that equation, fusion, kept hitting a wall. On January 1st, 2026, a team of scientists in Hefei, China, published a paper. Most of the world didn't notice. You just watched a video about it, and here's what I want you to think about. Every major energy breakthrough in history, steam power, oil, the grid, solar, nuclear fission, the countries that understood it first were the countries that led the century that followed. The density-free regime isn't just a physics paper, it's a signal. And the question is whether the rest of the world is paying attention. If you made it this far, drop a comment below and tell me, do you think China will be the first country to build a real fusion power plant? I read every single one. And if you want to see more videos like this, the stories the mainstream media isn't covering, make sure you're subscribed. We cover what matters before it's everywhere else. I'll see you in the next one.